Hello all. In this video, I'm going to discuss about one of the important numericals which is taken from the second chapter. Okay, here is the question. Two capacitors of capacitance of 1 microfarad and 3 microfarad are charged to 800 volts and 400 volts respectively. Find the common potential difference, the charge on each capacitor and the energy dissipated, lost, when they are connected to parallel. Okay, first we'll write down the given data. Okay, in this question, here are the given data. So first one, capacitance C1 equals 1 microfarad. That I can write it as 1 into 10 to the power minus 6 farad. Okay, then C2 equals 3 microfarad. We can write it as 3 into 10 to the power minus 6 farad. Then the potential is V1 equals 800 volts. V2 equals 400 volts. So here we have to find it out. Okay, the potential difference we have to find it out. Then the charge on the each capacitor, then energy dissipated or lost. Okay, let us see the formula here. The charge on the 1 microfarad capacitor before connecting is, I can write it as Q1 equals C1 into V1. So here Q1 equals 1 into 10 to the power minus 6 into 800. So that is 800 into 10 to the power minus 6 coulomb. Then the charge on the another capacitor is Q2 equals C2 into V2, that is 3 into 10 to the power minus 6 into 400, that is 3 4s are 12, 1200 into 10 to the power minus 6 coulomb. Now we have to calculate. These are the charges on each capacitor before connecting. Now we have to find it out, the common potential difference after connecting the two capacitors. Okay, then net charge means total charge. Stored in the combination is, you can say that Q equals Q1 plus Q2. Which I can write it here as Q equals, what is Q1? That is 800 into 10 to the power minus 6 plus 1200 into 10 to the power minus 6. If you add together, 800 plus 1200 is 2000 into 10 to the power minus 6 coulomb. This is the total charge stored on the combination. Now what I will do here is, effective capacitance when they are in the parallel connection is Cp equals C1 plus C2. Cp equals, C1 can be taken as 1 into 10 to the power minus 6 plus, and C2 is 3 into 10 to the power minus 6. Add together, we'll get 4 into 10 to the power minus 6 farad. Farad is the unit of capacitance. Now, common potential difference. V equals Q divided by Cp. Cp is capacitance in parallel combination, that is 200 into 10 to the power minus 6 whole divided by 4 into 10 to the power minus 6. So here 10 to the power minus 6, 10 to the power minus 6 will get cancel each other. 4 ones are 4 5s are 20, 0 0, that is 500 volt. That is the common potential difference. Now, charge on 1 microfarad capacitor is Q1 equals C1 into V. V is common here, that is Q1 equals 1 into 10 to the power minus 6 into potential is how much? The common potential is 500. That is 500 into 10 to the power minus 6 coulomb, which can be written as 500 microcoulomb. Now we have to find it out the charge on the another capacitor whose capacitance is 3 microfarad is Q2 equals C2V, that is 3 into 10 to the power minus 6 into 500. That can be written as 3 5s are 15, 1500 into 10 to the power minus 6 coulomb. That can be written as 1500 microcoulomb. This is the charge on 3 microfarad capacitor. Then net energy. Of the capacitor is U equals 1 by 2 C1 V1 square plus 1 by 2 C2 V2 square. Okay. Now what I will do here, we'll substitute the value U equals 1 by 2, and here C1 is, we know that 1 into 10 to the power minus 6 into 800 whole square plus 1 by 2 into 3 into 10 to the power minus 6 into 400 whole square. Now U equals 1 by 2 into 1 into 10 to the power minus 6 into 800 into 800 plus 1 by 2 into 3 into 10 to the power minus 6 into 400 into 400. 2 ones are 2 fours are 400, 2 ones are 2 twos are 200, right? Now U equals 1 into 10 to the power minus 6 is 10 to the power minus 6 into 4 8s are 32 Okay, 4 zeros plus 3 into 10 to the power minus 6. That is again 2 fours are 8. 0, 0, 0, 0, 4 zeros. So now U equals, what I will do is 10 to the power minus 6, I'll take common outside. 3, 2, 0, 0, 0, 0 plus 3 8s are 24. Okay. Now we'll add together. Okay, now what will happen? Okay, if you want, you can add it here. 32 and 24. That is 6, 5. Okay. Now what will happen? 5, 6, 0, 0, 0, 0 into 10 to the power minus 6. Further, we can simplify this and shifting the points. Okay, then we will left out with 0 point, because here 10 to the power minus 6 is there. So 6 points we can shift here. 6, 0.56, and energy SI unit is joule here. All right. Finally, energy stored after the parallel combination is U2 equals 1 by 2 into C1 plus C2 into V square. That is U2 equals 1 by 2 into 1 into 10 to the power minus 6 plus 3 into 10 to the power minus 6 into V is 500. That is the common potential. That is 500 into 500. Okay, now we can simplify this. Okay, 2 ones are 2, 250s are. Okay, now U2 equals 1 plus 3 is 4. 4 into 10 to the power minus 6 into 500 into 250. Okay, if we simplify this, we will end up with 0.5 joules. Okay, now the question is, in the main question, here we can see that what is the energy lost or dissipated when they are connected to parallel combination. So for that, I can write it here. Loss in energy, that is U1 minus U2 equals 0.56 minus 0.5. That is 0.06 joules. This is the dissipated energy during the parallel combination. Hope this, the numerical is clear. Kindly share with your friends and other groups. Thanks for watching. Kindly share your feedback here. Thank you very much.